Next we are discussing some important point, that is first point, integration of fx dx is suppose gx plus c. Then integration of a to b fx dx. Okay, this will come, integration of fx is what, gx, limit will come a to b. So this will come what, g of b2 minus g of e. This will come. But here whenever you are applying this one, that make sure fx must be continuous in the interval a to b. If it is discontinuous, then we can't apply this one directly. If it is discontinuous, suppose if I have, this is what, x equal to a, okay, and this is what, break is there, and here this point is what, x equal to b, then we can't apply this one. Okay, that means at this point, suppose c point, and this point is what, d point is there, then we have to do separate. So how it will come in integration? This was y equal to fx. Then how to write this one? Integration a to c fx dx plus integration d to b fx dx. Okay, then you have to apply this one. So what will come here? Gx, limit will come from a to c plus gx, and here limit will come what, d to b. This will come. So you have to apply like that. So here whenever you are applying this one, then make sure fx must be continuous in the interval, closed interval a to b. If it is discontinuous, then we have to take continuous interval. So this is a to c continuous and plus d to b continuous. So like that we have to separate. This is first important point. Second point is integration of a to b fx dx. Here if fx is greater than 0 for all x belongs to closed interval a to b, then we can say integration of a to b fx dx is always greater than 0 will come, positive will come. Second is what, if, third point is what, if fx is less than 0, okay, here limit is what, a to b. Okay, so a should be what, less than b should be there. Okay, a should be less than b. Okay, if a is greater than b na, then it will become minus, because in integration we should go left to right. So here a must be less than b, so then only this value will come what, greater than 0. Now if fx is less than 0, then integration of a to b fx dx, okay, will come less than 0. Here also fx is less than 0 for all x belongs to a to b. Okay, that's why we are mentioning here a to b. So a to b, that means a should be less than b, and here also a to b, a is less than b. Automatically it is mentioned here. Okay, so here what will come, this is also less than 0 will come. Okay, now fourth point is what, if I have integration a to b fx dx, if it is equal to 0, okay, integration a to b fx dx is equal to 0, then what is the meaning here? See here fx dx equal to 0, then it only indicates if some area is positive, then some area will be negative should be there. Okay, if some area is positive, then some area is negative should be there. That means curve should come what, it should come like that. So this is x equal to a, and this is what, x equal to b. Okay, so this area is what, negative, and this area is what, positive. Okay, so negative area and positive area should be equal in magnitude. Okay, so this is what, minus a, and this should be what, plus a. So minus a plus a should be what, 0. So we'll get integration will come 0. So what we can say from here, that from a to b, okay, at least one time fx will become 0. Okay, so this is what, y equal to fx. So if it is given a to b fx dx equal to 0, okay, then we can say that fx is having at least one root between a to b, in between a to b. We can take open also, between a to b. So we can say if a to b fx dx is 0, then we can say that fx is having at least one root between a to b, because some area is negative, some area is what, positive, then only they will be, addition will come at 0. Okay, next point, fifth point is, if fx is greater than or equal to 0 and fx is continuous in the interval a to b, and if integration of a to b fx into dx is equal to 0. Okay, so here fx is greater than or equal to 0 and fx is continuous in the interval a to b, and given is what, if a to b fx dx is 0. Okay, so when it is possible, if fx is positive, okay, fx is positive, then this integration should be greater than 0. But we are saying this integration was equal to 0 and fx can't be negative. Okay, so area negative not possible. Okay, either area should be what, positive, okay, or 0 possible. But when 0 is possible, so if integration a to b fx dx equal to 0, that means fx must be 0 in the interval a to b. Okay, in this interval fx must be 0. Okay, then only this is possible. Okay, next point, sixth point, if fx is greater than gx for all x belongs to a to b, then from here we can say that integration a to b fx dx always greater than integration a to b gx dx. Okay, for example, if I take graph, so this is x equal to a and this is x equal to b. Okay, so this is the graph here taking. So this is what, y equal to fx, and this is the graph of y equal to gx. So from here we can see that fx area is from here and gx area is what, this one. Okay, so fx is greater than gx. Okay, and if I take graph in denominator, okay, down, so this is the graph. So this should be what, y equal to fx, and this is what, y equal to gx. Okay, then only fx greater than gx possible. So here also this area and this area. Okay, so in magnitude wise gx area is more, but if I take algebraic sign, then fx area will come what, more. For example, fx area will be what, -2 and gx area will come what, -4. Okay, so magnitude by gx area is what, more, but -2 is greater than -4. -2 is what, greater than -4. So we can say fx area is greater than gx area. So if I take algebraic sign, then fx area will be more than gx, but magnitude by gx area will be more than fx, but integration will tell what, algebraic area. So integration of fx will be greater than integration of gx, whether fx is what, fx and gx both are above or fx and gx are both are below.